All right. How do we find the reference angle? What do we connect the terminal side to? Which axis? The x-axis. We really got to remember this, y'all. You cannot connect that to the y-axis to find your reference angles. You must connect to the x-axis. This is going to affect how we find the sine, the cosine, and the tangent of angles that are bigger than 90 degrees. So let's take a look at how we're going to do this. When you're putting triangles in other quadrants, you must not only pay attention to the fact that when you're on the unit circle, this is 0, 0. But remember, the x-axis is positive to the right, but these numbers to the left are all negative. The y-axis is positive when we go up, but as we go down, those are negative numbers. And that's going to affect sort of how we label the sides of our angles. So we're going to use pi over 4 as our reference angle and show you how it's going to work in all four quadrants. So let's draw the sine, cosine, and tangent, or let's draw the triangle or the angle for pi over 4. So remember, pi over 4 is that kind of 45-degree triangle straight to the right. To draw the reference triangle, we're going to drop straight to the x-axis and give ourselves a angle of 45 degrees here, or pi over 4. Well, since this is a 45-degree angle, what we have just drawn is a 45, 45, 90 triangle, one of our special triangles. So we can actually label these sides of this triangle as 1, 1, and square root of 2. Now, since we're going to the right on the x-axis, that's a positive 1. And since we're going up on the y-axis, that's also a positive 1. So now we can do SOHCAHTOA from this reference angle. So opposite over hypotenuse, 1 over the square root of 2, which we must rationalize. Adjacent over hypotenuse, 1 over the square root of 2, which we again rationalize. And TOA, opposite over adjacent, 1 over 1, or 1. So we get our sine, our cosine, and our tangent of pi over 4, which is in the first quadrant. But if we look at our next set of angles here, 3 pi over 4, well, that's the denominator minus 1. So that tells me that that is in the second quadrant. I'm going to drop a perpendicular from that terminal side. And again, our reference angle here is going to be pi over 4, or 45 degrees. That means we have just created a 1, 1 square root of 2 triangle. However, we need to be careful. When we are going up on the y-axis, that is a positive direction. But notice this side is going to the left, which is a negative direction. So this side must be labeled a negative 1 because it is on the negative x-axis. How is that going to change things? Well, this is the angle. I have to use this angle, the reference angle, which is by the origin. When I think of sine, so opposite over hypotenuse, that's a positive 1 over the square root of 2, or positive square root of 2 over 2 when we rationalize. However, when we do cosine, adjacent over hypotenuse, that adjacent is now a negative 1, which will mean that the cosine of 3 pi over 4 is negative square root of 2 over 2. And when we do TOA, opposite over adjacent, that's going to be 1 over negative 1, which is going to be a negative 1. So we can see when we get into the second quadrant, only sine is positive. Cosine and tangent are going to be negative things. And then when we flip these over, think about how is that going to affect cosecant, secant, and cotangent. Whereas over in quadrant 1, all sine, cosine, and tangent were positive. All right, let's look at the third quadrant and see how that changes things. So 5 pi over 4, that's 4 plus 1 is 5. That tells me we are in the third quadrant. Here is our angle, 5 pi over 4. We're going to connect to the x-axis. And remember, our reference angle over here is nice and easy. That's our pi over 4. This means we have a 1, 1 square root of 2 triangle. But as we go to the left on the x-axis, this should be a -1. And as we go down on the y-axis, this should also be a -1. Now, the next question you might have is, well, Mrs. Hoffman, what about the square root of 2? Shouldn't it be a negative as well? Okay, since we are going out from the origin, that is always going to be considered a positive. We're always going to consider the hypotenuse to be the positive side, but we need to pay attention to the x-axis and the y-axis, whether those sides are going to be negative or positive. Now, when we do our SOHCAHTOA, sine is going to be -1 over the square root of 2 or negative square root of 2 over 2. Cosine will be -1 over the square root of 2 or negative square root of 2 over 2. And tangent is going to be -1 over -1 or a +1. So we can see here in the third quadrant that sine and cosine are negative and tangent is what is the positive angle. As we run through the fourth quadrant, things are going to be very similar. So we're going to do 7 pi over 4. That's in our fourth quadrant. Connect it to the x-axis. Our reference angle is sitting here next to the origin, and it is, of course, pi over 4. Our sides are 1, 1, and square root of 2. This direction on the x-axis is positive. So the 1 that is on the x-axis is positive. However, going down on the y-axis is negative. So this guy will be a -1. And when we do our SOHCAHTOA, what we are going to find is that sine is negative square root of 2 over 2. Cosine is going to be positive square root of 2 over 2. And tangent is going to be -1. So in the fourth quadrant, we're going to get that cosine is positive and sine and tangent will be negative. Okay, taking a more global perspective of this, if you look in the first quadrant, all of the angles, all of the trig things are positive. But in the other four quadrants, only one thing is positive, the other two are negative. And there's a little mnemonic that can help us remember which of the trig things are positive and all the rest are negative. And that mnemonic is all students take calculus. So that it goes in order of quadrant. So A for all, students is S, T for take, and calculus for C. What that tells us is that all the angles are positive, all the trig functions are positive in the first quadrant. Sine is positive in the second quadrant. The other two, cosine and tangent, are negative. Tangent is positive in the third quadrant. Sine and cosine will be negative. And cosine will be positive in the fourth quadrant when sine and tangent are negative. So all students take calculus is a trick we're going to use as we go through more and more and more of these problems. So it's a good thing to memorize.